All right, so this is for the experimental design section. The experimental design is a brief description of what was done in the experiment. It must include what data was collected. Don't actually tell me the data, just tell me what kind of data was collected. The mass, the volume, the time, the temperature, what was collected. In this section, no personal pronouns. Really, in the whole lab report, you shouldn't use personal pronouns, but for this here, we're just saying no personal pronouns for this section. So that means no I, we, me, or they, right? You're using passive voice. So for example, instead of saying we stretched the steel wool, you would say the steel wool was stretched, right? Instead of we stretched the steel wool, okay? So that is passive voice. This is not a good experimental design yet because we don't have the data that was collected. We don't know what data we collected when we stretched the steel wool. So a better experimental design here would say the steel wool was stretched and the mass was measured before and after it was stretched, right? And there are a few different ways you can do that. You can type it to be more concise and succinct. So for example, we could say something like this. The mass of a steel wool ball was measured before and after stretching it out. So you see how we did passive voice, and you see how we talked about what data we collected, right? The mass of a steel wool ball was measured. We did not say, and I don't want you to say in the design part, you don't give your results. So you don't say, you know, the mass increased when we measured it. You don't say we measured it. You don't say we, right? This is past tense, or this is a passive voice. So you are not saying anything about your results. You're not saying that something would happen. You're not telling me that, you know, alcohol, you're not saying it dissolved successfully. You're not saying gas was produced, right? You're not giving me the results. You're just giving me the design of what you did and what you measured, right? So, okay, so hopefully that's clear, right? The mass of the steel wool ball was measured before and after stretching it out. Really, all of these are going to be really similar to this. You do not have to overthink it, right? One sentence, maybe two sentences. Focus on what you're actually mixing, right? If you didn't, you probably don't need to mention the vial, except like for this one, you might mention it, but you really still don't have to, okay? Just overall, I want you to work on your summary skills, 1-2 sentences. What did we do in that part and what were we measuring? All right. So that is that. Now for our diagrams portion, okay? And this really should say particle diagrams. And the particle diagrams, just like the histograms, you can do them on the computer and insert them there. Or you can take picture of ones that you did on paper and you can upload them here instead, okay? So I'm gonna show you real quick how do we do the diagram. So to get to the rubric, you're going to go back to the assignment in Google Classroom. You're going to click on that. And this is the rubric. And you do not have to write anything on here, okay? But this is just telling you what I am looking for when I'm grading your lab report. So I'm looking for all of these things. All right, so right now for these diagrams, particle diagrams, we're here in part 2. The diagrams need to show the atomic level, or the representation of matter at the atomic level before and after, okay? These are particle diagrams, right? And so you're going to need to draw these before and after of your experiment. So the example I went over in class was for station 2, where we did the ice. So for the ice, which one did we start with? For the ice that melted. Was the ice solid, liquid, or gas? It was solid. So we need to draw the solid. So that is me drawing the solid. So that is the representation of the ice. And then after it melted, what did we have? Solid, liquid, or gas? We have liquid. We'll go back to that video. How do we show liquids? Oh, it's more spread out, not filling up the container, right? But there's more space between the molecules. They're able to move more. So this right here is a good example for a particle diagram for station 2. So I would take a picture of this right here, take that picture, and just like I did with my histograms, I would upload it in here to my lab report. Right here under diagrams, okay, or right next to diagrams, right? So I would click insert, click image, and then select it from my computer, and then my particle diagrams go there. Make sure it's clearly labeled, right? This is before and after, and make sure you put it in the right section, right? So I know what I'm grading, what I'm looking for, okay? When you do that for all 6 sections, you are done with almost all of this lab report. Your purpose is filled out, hypothesis is completed, your experimental design is completed, you got your groups data table here, you got the data table for each section, you got the histogram and the diagram, particle diagram for each section. Now we just have to do our conclusion, all right? The best information on the conclusion is again back at our rubric. So let's go back to our rubric. At our conclusion, this is what we're doing for this conclusion. First, we need to identify which experiments showed no change in mass, explain why there was no change in mass, and a possible source of error. For number 2, identify which experiments showed a change in mass, explain why there was a possible, or explain why there was a change in mass and a possible source of error, and then state the law of conservation of mass in your own words. So that one you might need to look up, but then you're going to put in your own words. Don't just write down a bunch of words you don't understand. All right. Obviously, everything needs to be written clearly. Okay. Now, if you're just copying and pasting from somebody else, what's going to happen is you're going to end up with a 0. So make sure that you're doing this on your own. Okay, so it says identify which experiments showed no change in mass. So again, I want you to look at your class's data, whatever the most common result was, that's what I want you to say for this number 1 and number 2. So we're going to look back. If we go, let's say you're this student. All right, let's say you're this student right here, and this is your histogram that you made from this class data. Which result was most common, change or no change, right? 3 groups had no change and 3 groups had change, okay? So we're tied even and even. So now we're gonna look and we're gonna say, okay, which single one had the most? So we had 3 of these with 0, okay? And then we had 1 with just a very small change and then 2 with a big change. So which one result was the most common? It was the 0 here. So we're going to classify that this mass of steel wool had 0 change. So we are going to put in our lab report, in our conclusion, we're going to come down here to our conclusion, and it says see rubric here, right? So you go back to that rubric, and we're going to say that station 2 was one of the ones that had no mass change. Now, if your class data is different, okay, you have to put what your data has. I'm going to be looking at your class data. So don't just put it because I'm saying it here. Look at your class data, see what is the most common, and that's what you put as your conclusion. All right, I'm going to show you this example here in a second. Okay, so here's an example of just this one part of the conclusion, right? The first paragraph, I might want to do all the ones that had no change in mass. So I would say station 2 had no change in mass, explanation. The amount of steel wool didn't change, it only spread out further. And then it does say here in the rubric that we need a possible source of error. So this is, I really only want the source of error since we have the sources of error in our data table. If you did it correctly, that should be in your data table for each station. Here, you only have to put a source of error if that data does not match what should be. So I'm going to basically tell you the answer here. All of these stations should have no change in mass. All of them should have no change in mass, okay? So if you got a change of mass where you should not have, then I want you to tell me a possible source of error for that data, okay? And I'm not saying if you individually got that. Remember, we're looking at our group data. So if we go back over here, let's say that station 2, let's say that most groups had a change in data, had a change in mass for station 2. Let's say you're in a class where there were a lot of mistakes. That's fine. You're going to say this instead. You would say station 2 had a change in mass. The amount of steel wool should not have changed from it being stretched out. A possible source of error would have been if pieces of steel wool had dropped while stretching it out unnoticed. So again, we got that from our, we can kind of get that from our data table that we put up here from that section. Going back to our, see if I can get us to there real quick. Yes, going back here to this data table that we did right here, right? This one that we typed out on that Google Doc, possible sources of error. So you're really just kind of pulling from there as you need. And again, if you needed that list again and you're not sure what we talked about in class, these are all the possible sources of error that we talked about. So of course you have to make sure you apply the right one to whatever section, whatever station that you're talking about. Okay. So that is what you will type there. And then that next paragraph or next part, you're going to identify which one showed a change in mass. So you're just going to, skip a line or, then talk about those. So all the ones that had a change in mass and the possible source of error. And then section 3 right here, state the law of conservation of mass in your own words. Google it, put it in words that you make sense to you, make sure it's still right. And then you just type that. The law of conservation of matter says, and then you tell me what it says right there. And that should be the last sentence in your conclusion. And then we're done. You're done, and then you're ready to actually submit this assignment. Finally, y'all have been asking me for days and days and days, do we submit it? So now you're actually going to go and submit it. I have to upload a new video to show you how to do it on turnitin.com. Okay, so this is how I check for people who just copy it off of other people. So make sure you turn this in correctly on turnitin.com. See the video for that.